Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Mr. Joseph. Please, as you are watching this video, endeavor to subscribe, like, share and comment so that when I upload a new video or a new content, you'll be notified by YouTube so you are not lagging behind. So, in today's video, we shall be discussing chemistry, a topic called laws of chemical combination and quantum theory. As the name implies, laws. We shall be looking at different laws that are concerned with atom, element, and so on and so forth. Alright, the first atomist, of course, is known as what? Democritus. Democritus was the first person to actually state what the atom is. Now, John Dalton, he was my student. I taught him, yeah, he was my student. Is he your student? What? I thought he was my classmate. This guy, he was I was his mentor. Don't ask me the one I've discovered. Don't worry, I joined him. I don't know, the word is not balanced. They have included Mr. Explicit. It's okay, no problem. That aside. So, John Dalton. All of the postulates made by John Dalton, the fundamental one that still holds is the one he stated that all elements are made up of particles, tiny particles, called what? Atoms. He said that all elements are made up of what? Tiny particles called atoms. Alright? So, that is the first one which still holds. The second one is said that atoms are indivisible. Atoms are indivisible. And Sir Ernest Rutherford, I will not be too fast, Sir Ernest Rutherford said that, or stated that, via nuclear reaction or via nuclear fission, that an atom can actually be divided or split into three entities, which are the protons, electrons, and what? Neutrons. I believe these words are not new. Alright? Protons are positively charged, electrons are negatively charged, while these ones are what? Neutral. Alright? It means that they are neither positive nor negative. Now, I also told us in our initial video that Rutherford atomic model is also called what? Planetary model. Planetary what? Model. Why is it called planetary model? It is called planetary model because the electrons are found revolving round the atom, that is casting shadows on the objects they move about. So the electrons are just found outside the atom revolving. While protons and neutrons are found concentrated in the nucleus of an atom, which means that the nucleus is also what? Positively charged because of the presence of what? Protons. That is for that. So that law does not hold. The law that says that atoms are indivisible, it does not hold anymore, because Rutherford stated that through nuclear fission, the atoms can actually be divided or split. Alright? Take note of that. Number 3, it said that during a chemical reaction, atoms of the same element are combined in whole numbers. Atoms of the same element are combined in whole number. It also stated that atoms of the same element are exactly alike and they are different from the atoms of every other element. That law does not hold anymore. It doesn't. That law does not hold because through the process of isotopy, the phenomenon of what? Isotopy has kicked against that law. Isotopy, of course, was stated by Frederick Soddy in year 1813. Alright, what is the meaning of isotopy? Isotopy is a phenomenon in which two elements possess same atomic number, alright, but different mass number. What does that tell you? If these guys are having the same atomic number, different mass number, it therefore means that they have different number of what? Neutron. It means that they have different number of what? Neutron. Is that not correct? And we all know that the neutron of an element determines the physical features. Of an element, while the neutron determines what? The chemical features or the chemical what? Properties of an element. So please, the law that states that all atoms of a particular element are alike and they are different from the atom of every other element has been kicked against by the phenomenon called what? Isotopy, as postulated by Frederick Soddy. Alright, so please take note of that. Which one again? It's okay. I've given us that an element is number of tiny particles called atom. So that atoms can neither be created nor. Okay, good. That law also holds. It said that atoms can neither be created nor destroyed. Yes, it cannot be created. Neither can it be what? Destroyed. So all of the postulate of Dalton's law, or all of the postulate of Dalton's atomic theory. The first one I said holds, which said that elements are made up of what? Tiny particles called atom. The other one that said that atoms can neither be created nor destroyed during a chemical reaction. So it also holds, alright? Energy can neither be created nor destroyed during a chemical reaction, but it is transformed from one form to another. So please, that is all about John Dalton's atomic model, or John Dalton's atomic what? Principle. Now, we've established that already, and so first thing first, let's also state law of conservation of mass. The law of conservation of mass was stated by Dalton and his co-workers. The law of conservation of mass was stated by Dalton and his what? Co-workers. What did they say? They said that, or they stated that the mass can neither be created nor destroyed in a chemical reaction, which means that the law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Now, during the experiment conducted by Dalton and his co-workers, they constructed a tube called Dalton's tube. And this Dalton's tube was found to have two arms, arm A and what? Arm B. What did they do? While this tube was empty, it was weighed. It was what? Weighed. After that, what then happened? They reacted, or they introduced silver nitrate and sodium chloride into the tube. What then happened? You now have silver chloride and what? Sodium nitrate. On another note, they reacted silver sulfate with iron sulfate to produce a silver metal to produce what? A silver metal and what? Ferric sulfate. Alright? Now, they reacted this with this to produce this. While this experiment was going on, what happened? They introduced these entities into the tube. They turned the tube up and down. They now discovered that the mass of these reactants was also equal to the mass of what? The product. That is why they say that there is a mass of a substance cannot be what? Cannot be what? Destroyed in a chemical what? Reaction, alright? So they have the same masses. The mass of the reactants was found to be equal to the mass of what? The product. Now this equation is not balanced. I have 2 silver here, I have 1 here, so I'll simply put 2 at the back of this place. Alright, I have 2 iron here, I have 1, so I'll put 2 at the back of this place. It means that 2 is balanced with this. And SO4, you have 2 SO4 plus 1, that is 3. You have what? 3 here. This compound is called iron 3 sulfate. If I do not call it iron 3 sulfate, I can also call it ferric sulfate. It is called ferric sulfate because iron is gotten from a little word called ferron. Alright? That is where this ferric is coined from the Latin name of what? Iron. So that is for that. That was, however, they also stated that during a combustion reaction, the mass of the reactants will never be equal to the mass of the product, because during the reaction, some reactants are lost, or the quantity of the reactant is lost in the form of these, or what? Gas. Yes. If an entity is burned in air, or if an entity is reacted with oxygen, alright, some part of the reactant will definitely be lost, or as gas, or what? Heat. What is a combustion reaction? It's a reaction in which an element is burnt in air to produce carbon dioxide and water only, or it is a reaction in which heat is what? Generated. For you to measure the heat of combustion, you use an instrument called bomb calorimeter. It gave a formula. You have change in energy is equals mc squared. To calculate the mass of heat generated in a combustion reaction, use change in energy equals mc squared. This energy, this mass, and the c here represents speed of light, or velocity of what? Light, as the case may be, and it has a constant. It has it to be 2.99 times 10 raised to power 8 meter per second. This is what? The constant, alright? Take note of that, it is very, very important. So that is for law of conservation of mass. I believe it is clear enough. The next one is law of definite or constant. The law of definite or what? Constant proportion. Now, Uniben does not bring calculation on this very aspect. Alright? The question may come as stating a law, then asking you the person that stated it. You understand? So it's very important to know the law and the scientists that actually stated such law. Do you understand that? So calculations are not brought on this part of the topic. Take note of that. The law of definite or constant proportion. It says that atoms of all elements are exactly alike and are different from the atoms of every other element. I stated it before, and this law as stated by Dalton has been kicked against, alright, by Frederick Sobey like Frederick Soddy in the 1813 through a process called isotopy. I've explained that already, so because of time, let's just go straight to the point. So that is all about the law of definite or constant proportion. It stated that atoms of all elements, or atoms of the same element, the word is the same there, please. Atoms of the same element are precisely or exactly what? Alike, and are different from atoms of every other element. Which means that, for example, now if sodium chloride is prepared in Benin, and the same sodium chloride is prepared in Asaba, what do you observe here? The same combination, right? Sodium, chlorine. So please take note of that. Which means that the same sodium chloride in Nigeria, or the same sulfuric acid in Nigeria, is also the same in sulfuric acid produced in America. So they have the same constituent. They have the same constituent, which is H2SO4. That is what? Sulfuric acid, hydrogen, sulfur, and what? Oxygen. Another one is the law of constant composition. The law of constant composition or definite proportion. Alright, the law of constant composition or definite what? Proportion. This law was stated by Joseph Louis Proust. The law of constant composition or definite proportion was stated by Joseph Louis Proust. What did he say? He said that this law, let me write it. This law states that all pure samples of a chemical compound this law states that all pure samples of a chemical compound contain what? The same element. Contain the same element combined. Alright? Contain the same element combined in same proportion. As I initially told you, take note of the law and the person behind it. You are good to go. Alright? This law states that all pure samples of a chemical compound contain the same element combined in same proportion. And that law was stated by Joseph Louis Proust. On your textbook, they only gave you Proust. Right, so this is the full name of the scientist. Take note of that. Another law is law of multiple proportion. Law of what? Multiple proportion. The law of multiple proportion. This law was actually stated by this same guy, John Dalton. John Dalton also stated the law of multiple proportion. What did he say? This law states that if an element A, this law states that if an element A reacts to produce or combine to form more than one chemical element. Okay, how do I put it now? Okay, good. Let me put it this way. This law says that if two elements if two elements A and B, this law states that if two elements A and B combine together to form more than one chemical compound, this law states that if two elements A and B combine or react to form more than one chemical compound, therefore the several masses of B, therefore the several masses of B that react with A are combined in same ratio. The law of multiple proportion, which is the third law now, right? This law states that if two elements A and B react or combine to form more than one chemical compound, therefore the several masses of B that react with A are combined in same ratio or in simple ratio. All right, don't worry, in our next class I shall be using some questions to explain these laws properly. Just as I said, just take note of the laws and the person who stated the law. It is very, very important. All right, the fourth law is the law of conservation. The law of conservation of what? Energy. The law of conservation of energy, and this law was stated by Julius Robert von Mayer. All right. The law of conservation of energy was stated by Julius Robert von Mayer, together with James Prescott Joule. Julius Robert von Mayer and James Prescott Joule actually stated the law together. The law states, of course, not the law, right, that energy cannot be created nor destroyed in a chemical reaction. What happens? It can be transferred from one form to another. Of course, you and I know the processes that are behind photosynthesis in green plants. The chlorophyll traps sunlight in the form of what? Solar energy. They don't make use of solar energy. What happens? The solar energy that has been trapped by the chlorophyll is converted into what? Chemical energy, which they use in photosynthesizing. So please, it is neither created nor destroyed, but it can be transferred or transformed from one form to another. That is the fourth law. Now the fifth law, I believe this has been comprehended. Now the fifth law, which is a law of reciprocal proportion. I'll rub out this part. The law of reciprocal proportion. All right, we have law of reciprocal proportion. Law of reciprocal proportion. The law is a bit long. Alright, I think I'll write it. This law states that if an element A reacts with other elements, I don't like this one, with other elements B, C, and D, then, the several masses of B, C, D, then the several masses of B, C, D that combined with the fixed mass of A, take note of the word, fixed mass. This law states that if an element A reacts with other element B, C, D, then the several masses of B, C, D that combined with the fixed mass of A are in same ratio, or simple proportion with then the several masses of B, C, D that combined with the fixed mass of A are in same ratio or simple proportion of the several masses of B, C, D are combined with each other. Now, this is the longest law under the laws of chemical combination. Right, this law says that if an element A reacts with other elements B, C, and D, then the several masses of B, C, D that combine with the fixed mass of A are in same ratio or simple proportion of the several masses of B, C, D that combine with each other. Okay? That's combined with what? Each other. So this is just the law of reciprocal proportion. In our next class, I will use a different video to use some calculations to explain these laws. Laws of reciprocal proportion, law of constant composition, law of definite proportion. Of course, I've explained the law of what? Conservation of what? Mass. So, please subscribe so that when I upload a new content, you will be notified by YouTube. We are not done with today's class, alright? That's why I don't want to take calculations today. Let me just go straight to the laws. Alright, so we are done with the first part, and the next one is what? Quantum theory. Bohr's theory, that is Niels Bohr. Niels Bohr's theory is used to explain hydrogen atom or quantum physics. Niels Bohr's experiment is concerned with what? Quantum physics. Take note of that. Now, during this experiment, a known electricity was passed into a discharge tube. This tube was having hydrogen molecules. Was having hydrogen molecules. The electricity that was passed through into this tube was, of course, a low temperature. Please, low temperature. As soon as electricity was passed into the tube containing hydrogen molecules, what happens? These hydrogen molecules split into hydrogen atoms. Your question may be, what is the difference between hydrogen molecules and hydrogen atoms? Look at it here. H2 is hydrogen what? Molecule. H is what? Hydrogen atom. So which means that 2H plus H, I'll get what? Which means that 2 or more hydrogen atoms, I'll get what? A hydrogen molecule. So 2H will produce a molecule. Take note of that. So, the experiment did not stop there. During this experiment, it was also observed that there were some radioactive emissions. There were some radioactive emissions. I think they are about 4 in number, right? They are about 4, yeah. About 4 in number. Alpha, beta, gamma, and delta. So this is noted as alpha, beta, gamma, and what? Delta. So please take note of the symbol. All right, the symbols are very, very important. So please, Niels Bohr's experiment is used to explain quantum physics, and it is associated with what? Hydrogen atom. We are almost coming to the end of today's video. All right, so please take note of that. Let me conclude the class by giving us Balmer's formula. Please note that lambda is equals C over what? V. Right? Is equals C over what? V. Of course, you know lambda stands for what? The wavelength. V, you have V as velocity, that is velocity, or which is expressed as what? Frequency. That is, you can use this to be what? Frequency, and of course the C is what? The speed of light. The speed of what? Light. Please take note that in spectroscopy, wave number, which is denoted as, all right, wave number is denoted as what? This, or you can say in spectroscopy, frequencies are denoted as what? Wave number. And wave number is expressed as the reciprocal of the wavelength. I said this very one is what? The wavelength. Wave number is expressed as what? The reciprocal, alright, of what? The wavelength. And this is what? Per meter. Take note of that. Then Balmer. This is what called Balmer principle, Balmer formula, like Balmer formula. That's in year 1885. He actually coined a formula. That formula is wave number is equals to 1 over lambda is equals to ROH open bracket 1 over n1 squared minus 1 over n1 squared. So this ROH is a constant. That is, ROH stands for Rydberg constant. Rydberg constant, and it has a constant as 109,678 centimeters. So this is Rydberg's constant. Take note of that. Whenever you are given a question, you must impute this constant into this very part, which is what? ROH. So, is there any part I've not actually dropped? Okay, your n here, your n could be 1, could be 2, could be 3, could be 4, as the case may be. Now, when you're, okay, how do I put it now? Okay, let me do like this. Lima, Balma, past gen, brackets, and P form. Now N1 you have it to be 2, 2 is 3, 3 is 4, 4 is what? 5, and 5 is what? 6. You see that? So you have 2, 3, 4, you have 3, 4, 5, you have what? 5, 6, you have 6, 7, you have 7, 8. You see, so they will ask you, calculate the wavelength. Calculate the wavelength of let me put it like, let me coin a question. Calculate the wavelength of the second and third line of Parken series. Parken series. Calculate the wavelength of the second and third line of Parken series. What does that say? It means that the second line, which is this, is Parken. Look at Parken here. This is the first line. This is the second line, which is what? 5. Alright? Which means that here now, N1 here becomes what? 5. Then the third one is what? 5. So which means this is N2. Is it 5 now? 4. Sorry. Okay, 5. Oh, 5 then 6. Alright, so which means here I'll be having, in place of N1 squared, I'll put what? 5. In place of 1, okay, is it 1 now? Sorry, it's 2 now. In place of, because 1 and 2. So in place of N2, I'll put what? 6. It becomes 1 over 5 squared minus 1 over what? 6 squared. So that is for that. At this point, we'll call it a day. Please, you cannot twist this. I have an acronym. I said line Bams Pascal. Line, they talk like line Bams Pascal. Alright? Bracket P font. Alright? Or you can just say font, like Egona Piotali, money. Alright, so at this point, we call it a day. Thanks for watching. Do have a wonderful day. Please, before I conclude this, please, those of you that have strong body odor, they bath well. Wash the headquarter, wash everywhere, wash your armpits. Wash it, use iron sponge to scrape your armpits, wash the headquarter. Yes, I don't know the name of headquarter, but I just said you should wash your what? Headquarter. I was in a bus coming this morning, Jesus Christ of Nazareth. The body odor I smelled was as pungent as cassava, as 5 days soaked cassava. It choked. I said, Jesus Christ of Nazareth, please, if you want to take your bath, wash your armpits and your genital region. It's very, very important. Alright, thanks for watching. Please subscribe to my YouTube channel so that when I upload new content, you'll be notified by YouTube. Thanks for watching.